Bright Duty. Every student matters.
So let's move on to some more questions here. Now form a pair of linear equations in the following problems and also find their solutions graphically. So first we need to form an equation, then we need to draw the graph and see whether there is a common point or not to find the solution. 10 students, so the first part here is 10 students of class 10 took part in mathematics quiz. If the number of girls is 4 more than the number of boys, find the number of boys and girls who took part in the quiz. So let us say number of boys was X and number of girls was Y. Okay, and see 10 students participated in this quiz. So clearly X plus Y is equal to 10. This is the first equation that we can form. Okay. Now the second one is the number of girls is 4 more than the number of boys. So Y is 4 more than X, right? And these are the two equations that we can form. So this equation can be written like this: X minus Y is equal to minus 4. So this is the second equation here. Now we need to solve this system of equations graphically. So we need to draw graphs. X plus Y equal to 10, X minus Y equal to minus 4. So we will make tables for each of these equations. X, Y. Okay. Now if you put X equal to 0, you will get Y equal to 10. If you put Y equal to 0, you will get X equal to 10. Here if you put X equal to 0, you will get Y equal to 4. If you put Y equal to 0, you will get X equal to minus 4. Okay. So let's draw the pair of straight lines on this graph. This is 1, 2, 3, 4, 5. We would require up to 10. Okay. And on the negative side, we would require up to minus 4. So let me take up to minus 5. And on the y axis, I would require up to 10. And on the negative side of y axis, I do not require any number. How do I know that? I just saw these values for y: 10, 0, 4, 0. So I require up to 10 only, right? So as per my need, I made this graph here, right? So let's draw these points: x 0, y 10. So x 0, y 10. So this point is 0, 10. X 10, y 0. So x 10, y 0 is this point. What will be the graph? The graph will be a straight line passing through these two points. Okay. And what is the name of this line? X plus y equal to 10. Another line that we can form is this one. 0, 4 is one point. 0, 4. So this point is 0, 4. Another point is minus 4, 0. So minus 4, 0 is this point. So the straight line or the line passing through these 2 points will be this. So this point is common to both the lines. This point is common to both the lines, hence it will give us the required solution. If you draw these lines on a graph paper, you will exactly find this point here. So what will you do is, you will drop a perpendicular here and see where it meets on the x axis, which will give you the value of x coordinate of the solution. So but this is the rough diagram here, so we cannot comment exactly what will be the solution here, but we can check that x, if x is 3 and y is 7, does it meet this requirement? X 3, y 7, 3 plus 7 is 10. Yes, it meets the requirement. Let us check the second one. If x is 3, y is 7 it still meets the requirement. So, it is a rough diagram, but it still gives us the perfect solution here. But you need to draw these graphs on graph paper if you need to solve the questions graphically, right. So, x is equal to 3, y is equal to 7 is the solution, right. Why? Because this point is 3, 7 and this is common to both the lines, hence it will give us the required solution. So, x equal to 3 means number of boys is 3 and number of girls is 7. Okay. Now, let us look at the second part of this question. So, the second part of this question is 5 pencils and 7 pens together cost rupees 50 and 7 pencils and 5 pens together cost rupees 46. Find the cost of one pencil and that of one pen. So, if I consider the cost of one pencil and one pen as x and y, let us consider or let us assume the cost of one pencil as x rupees and the cost of one pen as y rupees. Now, let us look at the situation. 5 pencils and 7 pens cost rupees 50. So, 5 pencils means 5x rupees and 7 pens means 7y rupees and it is equal to rupees 50. Okay. So, this is the first equation that I can form out of this question. Second situation is 7 pencils and 5 pens both together cost rupees 46. So, 7 pencils means 7x rupees and 5 pens will cost me 5y rupees and this total cost is 46 rupees. So, this will give me my second equation here. Now, I need to find the solution again. So, again I need to make this graph. Okay. So, I would suggest you to pause this video and make this graph on a graph paper so that you can find the exact solution. Okay. I'll make the rough diagram here just for our reference. Okay. That might not give exact solution, but it will be good for your understanding this concept. This is 5x plus 7y equal to 50. This is 7x plus 5y equal to 46. Okay. If I put x equal to, let us say, 3, why? Because it will make it 15 and 50 minus 15 will become 35, which is divisible by 7, right. So, this will give me y equal to 5. Okay. 7 into 5 is 35 and if I put x equal to, can I make another such integral solution? If I put x equal to, let us say, no, I cannot find any other integral solution for this. So, for positive x, right. If I put anything negative, then I have to spend a lot more time. So, let us put any other value. Let us put x equal to 2. Okay. What will be value of y? It will be 40 by 7 in that case, right. For x equal to, let us solve this one. For x equal to 1, what will be the value of y? It will be equal to 39 by 5. Okay. What you need to do is you put x equal to 1 here and it will become 7. You need to take 7 on the right hand side. So, it will become 39 and 39 divided by this 5 will give me my y. So, another value, if I take x equal to 3, let us say. If I take x equal to 3, it will become 21. 7 into 3 is 21. 21 if you subtract from 46 will give you 25. So, 25 when divided by this 5 will give you 5. So, fortunately, we have got a common point in these two. What does it mean? That this point will serve as a solution for these pair of linear equations. So always try to find a common point when you know that there will be a solution, right, for these two equations. And how do you know that? You could have compared these. 5 by 7 is not equal to 7 by 5, so you know that there will be a solution, right? And if there is a solution, try to find this solution right here, okay, so that you know which point will be common to both these lines. So now I can make this graph easily. Okay, this is 1, 2, 3. This point is approximately 5 point something, right? So 4, 5, 6, and so on. 1, 2, 3, 4, 5, 6, and so on. On the negative side of y-axis, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, and so on here. Okay. So to draw this point, 3, 5. 3 on the x-axis, 5 on the y-axis. So this is the point 3, 5. And 2, 40 by 7. So 2 on x-axis and 5 point something, let us say this is the point 40 by 7. So it will be somewhere here. Okay. So this is like this. Okay, this is one line that we have got, and name of this line is 5x plus 7y equals 50. Okay. Now let us look at this line here. 139 by 5. 39 by 5 is approximately 7 point something, right? Or you can find the exact value. It is 7.8. Okay. So 1 and 7.8. 1, 7.8, let us say, will be somewhere here. This is 7, and let us say this is 7.8. So this is another point which is 1, 7.8, and this point is the same point, which is this one. So this graph will be like this, and we know that these two lines are intersecting at this point, hence this will be our solution. So x is equal to 3 and y is equal to 5. This is our final solution for this question. What is x? X is for one pencil. So what was the question? Find the cost of one pencil and cost of one pen. So cost of one pencil is x and cost of one pen is y. So this is cost of one pencil and this is cost of one pen. Okay, this is the graphical solution of this question. Now this question is easier in comparison to first question. Why? Because we just need to observe and comment. On comparing these ratios, find out whether the lines represented by following pair of linear equations intersect at a point, are parallel or coincident. Just to revise, let me tell you, if I have got a1 by a2 is not equal to b1 by b2, then these lines will intersect. If a1 by a2 is equal to b1 by b2 and is not equal to c1 by c2, then these lines will be parallel. And if a1 by a2 is equal to b1 by b2 equal to c1 by c2, then these lines will be coincident. Okay. Now look at these lines. This is a1, this is a2, right? These equations are to be compared with these general equations. a1x b1y c1 equal to 0, a2x plus b2y plus c2 equal to 0. Okay. So when you compare, a1 is 5, c1 is 8, b2 is 6. Okay. This is how you compare. So now in these two lines we can see 5 by 7 and minus 4 by 6. So clearly these are not equal, right? Hence these lines are intersecting pair of lines, intersecting lines. Okay. Let us look at the second one here. You just write these coefficients like this: 9 by 18, 3 by 6, 12 by 24. Now you observe, what is 9 by 18? It is 1 by 2. 3 by 6 is again 1 by 2. 12 by 24 is again 1 by 2. Hence these three ratios are equal to each other. Right? 9, then double of 9, 3, double of 6, 12, double of 12. Right? So these are essentially equal to 1 by 2. Hence these two lines are coincident lines. Why? Because if you multiply the first equation by 2, you will get the second one, right? So these two represent the same line, okay? Or in terms of pairs of straight lines, we say these are coincident lines, okay? So this is also a consistent pair of lines, okay? Look at these coefficients, 6 by 2, minus 3 by minus 1, 10 by 9, okay. 6 by 2 is just 3 by 1 and minus 3 by minus 1 is again 3 by 1, but this is 10 by 9, right. So these two are equal, but this is not equal to these, right. So these two are equal, but this is not equal here. So what kind of lines are these? These are parallel lines, right. Why? Because we will comment like this, that A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2. Hence, we will say these lines are parallel lines, okay. Now again, on comparing these ratios, find out whether these linear equations are consistent or inconsistent. So when will these be consistent? When we have a solution, one solution or more than one solution. More than one solution, we have just one case, that is infinite solution. So for consistency, we have got two situations, A1 by A2 is not equal to B1 by B2, and another case is A1 by A2 equal to B1 by B2, then C1 by C2 will also be equal. So in these two cases, we will have consistent lines, and in third case, where A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2, this is parallel lines, so inconsistent. So let us look at these. Here in first case, 3 by 2, 2 by minus 3, obviously these are not equal. So these lines are intersecting lines, hence consistent, right. Second question is 2 by 4. I am writing these coefficients, minus 3, minus 6, this coefficient, and 8 by 9. Now let us see whether these are equal or not. So 2 by 4 is nothing but 1 by 2, minus 3 by minus 6 is again 1 by 2, but it is not equal to 8 by 9. So these two are equal, but it is not equal to 8 by 9. So these are equal, but not equal to this. So what kind of lines are these? These are parallel lines. Hence, inconsistent, right. So this is our answer, inconsistent, okay. Look at these lines, 3 by 2 by 9, 5 by 3 by minus 10. Obviously when there is a negative sign here, these two are not equal, okay. So straight away we can say these are intersecting lines, hence consistent, right. Look at these, 5 by minus 10, minus 3 by 6, 11 by minus 22. So by cancelling these, you will get minus 1 by 2 here, minus 1 by 2 here, minus 1 by 2 here. So all these three ratios are equal, and these are equal to minus 1 by 2, okay. But the concern is that these three are equal, right. So these lines are coincident lines, hence consistent. Why? Because these will give us infinite number of solutions, so consistent. look at this pair of linear equations. 4 by 3 divided by 2, 2 by 3, 8 by 12. So this is nothing but 4 by 6. So 4 by 6, 2 by 3, 8 by 12. 4 by 6 is nothing but 2 by 3, and 2 by 3 is 2 by 3. So 4 2s are 8, 4 3s are 12. So it is also 2 by 3. So all these three ratios are equal, right? Hence the lines are coincident lines and this system is consistent. Why? Because it is giving us solutions, infinite number of solutions. Okay. In this case, we need to see whether these are consistent or inconsistent. If consistent, in that case, we need to draw its graph and find the solution. So let us see. X plus y is equal to 5, 2x plus 2y equal to 10. You can clearly see double of x, double of y and double of constant. So we know that the ratio a1 by a2 equal to b1 by b2 is equal to c1 by c2, and it is equal to 5 by 10 or 1 by 2, right. So we can say this is consistent pair of linear equations, and to draw its graph, x plus y equal to 5, we will make a table here. X, y, if you put x equal to 0, y will be 5. If you put y equal to 0, x will be equal to 5. And similarly, you can make this graph here. 2x plus 2y equal to 10, right? And if you take x equal to 0, y will be equal to 5. And if you take y equal to 0, x will be equal to 5. Okay. I've taken same points here to draw these lines, this pair of straight line, but you can take different points. Why I am taking these points as same points? Because I am not using this graph here. Okay. So, but you are using the graph, so you can take any different 2 points, but you will see that both the lines will be exactly same line, right. So 1 2 3 4 5, 1 2 3 4 5, and this is the negative side, this is the negative side, so I don't require them. Okay. So one point is 0 5, which is this one, this is 0 5. Another point that I have got is 5 0, so this one. So the line that I am looking for will pass through these 2 points. Okay. And this line is for both these equations. Hence, this is a consistent pair of straight lines and will give us infinite number of solutions. So we need to find the solution. We can have infinite number of solutions, out of which you can write 2 solutions like this, 0 5 and 5 0. 0 5 5 0 are 2 solutions. If you need to write more solution, you can keep on writing more solutions by just finding solution for one equation, because these will have infinite number of solutions. If you put y equal to 1, x will be equal to 4, y 2, x will be 3. So you can keep on writing these solutions. Okay. Now look at this pair here. It is again x triple of x, y triple of y, but it is not thrice of this constant term here. So out of these equations, I can say a1 by a2 is equal to b1 by b2, which is equal to 1 by 3, right. But it is not equal to 8 by 16. Hence, lines are parallel. So the pair of linear equations is inconsistent, and we don't have to go any further. Okay. Look at this third part here. 2 by 4, 1 by negative 2. So these are clearly not equal. Hence, intersecting lines, or you can say consistent pair of linear equations. So this is consistent. Now we need to draw the graphs. So this table is for 2x plus y minus 6 equal to 0, x here, y here. Okay, we'll make another table for 4x minus 2y minus 4 equal to 0. So x, y. Okay, put value of x as 0. So y will be equal to 6, right? If I put value of y as 0, x will be equal to 3. Okay, I hope you understand this by now, how I am getting these values. I put x equal to 0 in this equation, so this part becomes 0. So y minus 6 equal to 0 will make it y equal to 6, and so on. Okay, here if I put x equal to 0, what will be y? Minus 2y will be equal to 4, so y will be equal to minus 2. And if I put x equal to 3, let us say, so it will become 12. 12 minus 4 is 8. So minus 8 by minus 2 will become 4. So if I put x equal to 3, y will be 4. Let me show you. 4, I put x equal to 3, minus 2y minus 4 equal to 0. So this is 12. 12 minus 4 is 8, minus 2y plus 8 equal to 0. So minus 2y will be equal to minus 8, hence y equal to 4. Okay, so I have given you these set of points. I want you to draw this graph on graph paper yourself, and you will see that the point where these two lines intersect will be the solution of these two equations. Okay, so I want you to do the graphical part yourself in this case. Okay, 2 by 4 minus 2 by minus 4 minus 2 by minus 5, right? Now you clearly see that this is 1 by 2, this is again 1 by 2, but it is 2 by 5. So these two are equal, but these are not equal to this. So these are equal, but it is not equal. So parallel lines, hence inconsistent. So we don't have to go any further. Okay, let us look at this question here. Half the perimeter of a rectangular region. So it is talking about half the perimeter, whose length is 4 meter more than its width, right? We are talking about half the perimeter of a rectangular garden, whose length is 4 meter more than its width. The half the perimeter is 36 meter. Find the dimensions of the garden. So let us first of all assume the dimensions. Let the length is x meters and the width be y meters. Okay. Now look at the condition here. Length is 4 meter more than its width. So x is equal to y plus 4. Equation number 1. Okay. Look at the rectangle here. The length is x, width is y. What will be the perimeter? Perimeter is this boundary, right? So 2x plus 2y is the perimeter, and half the perimeter is given equal to 36 meters. So half of it is equal to 36 meter. This will give us our second equation, which is x plus y is equal to 36. So this is our second equation here, right? Because this is my perimeter and half the perimeter is equal to 36. So 2x, if I take 2 common, 2x plus y divided by 2, this 2 will get cancelled. It will give us x plus y equal to 36. So this is my second equation. Now first one can be written as x minus y equal to 4 also. Okay. Now I need to solve these two equations and find the dimensions of this garden, right? To solve these two, you use the graphical method, as it is the exercise based on graphical method. Otherwise, when we proceed with this chapter, we will learn about substitution method, elimination method also. So this will be easier to solve with using those methods. But right now you make this graph and solve it. So you make a graph for x plus y equal to 36 and x minus y equal to 4 by taking these two tables. Let me make the tables for you, and then the graph you make it yourself. So x, y, x, y. This one is for x plus y equal to 36. This is for x minus y equal to 4. Okay. If I take x equal to 0, y will be 36. If I take y equal to 0, x will be 36. In this case, if I take y equal to 0, x will be 4. And if I take x equal to, let us take 8. Okay. Then this 8 can be taken on this side. 4 minus 8 will become minus 4. So y will become 4 in that case, right? So I have given you 2 points for this equation and 2 points for this equation. You make these graphs and see that the common point or the point of intersection of these two lines will give you the solution. Okay. I can tell you the solution, that it will be equal to, x will be equal to 20 and y will be equal to 16. You can verify it from these equations also. Let us take the third point here. If you take x equal to 20, what will be y? 20 plus y 36, so y will be 16, right? And in this equation, if you take x equal to 20, so 20 minus y is equal to 4 will give us y equal to 16. So this point will serve as your solution, and the answer will be for length will be 20 meters and width will be 16 meter. But the purpose of this question is to solve it graphically. So I suggest after you make this table, you just plot these points on a graph and see the point of intersection will be 20, 16. Okay. Given the linear equation 2x plus 3y minus 8 equal to 0, write another linear equation in two variables such that the geometrical representation of the pair so formed is intersecting lines, parallel lines, coincident lines. Now again we know about these ratios, a1 by a2, b1 by b2, c1 by c2, right? When these three are equal, it is coincident lines. When these two are not equal, then these are intersecting lines. When these two are equal but not equal to c1 by c2, these are parallel lines. So this much knowledge we already have. Now one equation is given as 2x plus 3y minus 8 equal to 0. So first part, we need to form another equation for so that that line intersect with this line. Okay. So let me take 3x here. Okay. With y, what coefficient can I take, or let us think other way around. What is the coefficient that I cannot take? I cannot take a coefficient which will make this ratio 2 by 3, right? I cannot take some coefficient which will make this ratio 2 by 3. Otherwise, I am free to take any other coefficient. Let us take, I take minus 3. It is clearly 2 by 3 is clearly not equal to 3 by minus 3. I have taken negative sign here, so that reduces all the confusion here. So this is not equal. So I can take anything here. Let us take 7 equal to 0. Now these two lines are intersecting lines. Other student can take 7 here, 8 here, right? 9 here. So the answer will vary. Okay. Every student will not have a same answer for this question, but this is perfectly a correct answer here. Okay. if I ask you what is the coefficient that I cannot put here, I cannot put a coefficient which makes it 2 by 3. So 2 by 3 equal to 3 by x, let us say. I cannot put x here. What is the value of x? X is equal to 9 by 2. So I cannot put 9 by 2 here. If I put plus 9 by 2 here, 2x plus 3y minus 8 equal to 0, 3x plus let us say 9 by 2 y plus 7 equal to 0. In this case, these lines are parallel lines. So I cannot, for intersecting lines, I cannot put 9 by 2. And for parallel lines, I'll have to put 9 by 2 here. And these constants have to be different, right? The ratio of these constants cannot be 2 by 3. So I've taken it plus 7, so it is clearly not 2 by 3. So it gives us solution for our second part here. So these two lines are parallel lines. Using the same equation, I'll write equation for coincident lines. So third part. Let me use the first part as it is, 2x plus 3y, 3x plus 9 by 2 y. Now the next part has to give the same ratio, that is 2 by 3. So if I take, let us say, 4 here, then I'll have to take 6 here. Now these two lines are coincident lines. These two lines are coincident lines, right? Why? Because if I multiply this first equation by 3 by 2, it will give me the second equation here. So this pair of straight lines or this pair of linear equations will give me coincident lines. Okay? So this is how you will comment about this question. Now draw the graphs of the equations. Determine the coordinates of vertices of a triangle formed by these lines and the x-axis. Also shade the triangular region. So we need to draw x minus y plus 1 equal to 0 and 3x plus 2y minus 12 equal to 0. So we will make a table x, y, another table for this one, x, y. Okay. If I put y equal to 1, then x will be equal to 0, because 1 minus 1 is 0, so x equal to 0. And if I put x equal to, let us say, 1, then 1 plus 1, 2. So minus y is equal to minus 2, hence y will be equal to 2. Similarly, in this, if I put x equal to 0, 2y will be equal to 12, hence y will be equal to 6. If I put y equal to 0, then 3x will be equal to 12, hence x will be equal to 4. Okay. Now you need to draw these two lines on a graph paper and see what triangle is getting formed. For example, if you draw these two lines, this will be x, this will be y, x dash, y dash, 1, 2, 3, 4, 5, 6 and so on, 1, 2, 3, 4, 5, 6 and so on. Now if you have got a graph paper and you draw these points carefully, you will get the exact point of intersection. So one point is 0, 1, which is this one. Another point is 1, 2. So 1, 2. So this straight line is x minus y plus 1 equal to 0. And this line will pass through these 2 points, 0, 6, 4, 0. 0, 6 is this one and 4, 0 is this one. Now if I draw this line here, this point of intersection will give me the solution. Okay, and this point is 2, 3, right. So, this will give me the solution for this pair of linear equations, and this will also act as a vertex for this triangle. You see, if you use this x axis and these two lines, you see that this is the triangle. The triangle that I am shading right now is the triangle formed using these two lines, and the vertices are vertices. One of the vertices is this 2, 3. One vertex is 4, 0. This vertex will be where y is 0, right? When y is 0, what will be the value of x? For this line, when y is 0, x will be equal to -1. So, this point is -1. Okay. Graphically, it will be clear to you which point is this. So, if you need to talk about vertices, this point is -1, 0. So, there will be this triangle with these vertices, and I have already shaded this region. This is the triangular region that you need to shade. Okay.